Hey guys, it's Vince. This is the second part of a two-part video series that I wanted to create to cover the infamous Gecko Drive G540. I only carry the Gecko Drive G540 in my store along with the G251X drivers, which are the same internal drivers that are used inside the chassis of the G540. Gecko, again, it's infamous. If you guys have any questions on Gecko, please go to geckodrive.com, do some research. They're top-notch drives. They are supported in America, manufactured in America. Their warranty is pretty much bulletproof, one-year factory warranty, direct replacement, no problems with warranty or support, whether it be phone, email, whichever format you want to use. That being said, please watch the first video. It's the manual overview of the G540. It'll really just kind of enhance what you're about to learn about the drive now, and hopefully it'll eliminate a lot of questions I get and a lot of questions in general. A lot of crap online about Chinese drivers and the cheaper ones. This drive, for the price per drive, I would say price per potential, is probably the best overall drive on the market, being whether you're dealing with a 3-foot chassis CNC or even a Grizzly mill. And I'm going to cover some variables on what I'm talking about. But overall, I'm going to jump right in. Again, I invite you to watch video 1 so that you're up to spar on the manual itself. Now what I want to cover, again, I'm going to just reiterate because now I have the real drive in front of you. You've got, again, 4-axis X, Y, Z, A. This is a digital stepper driver system. To cover in lowdown some of the features that are missed on the drive initially when you get it. You can see here, and I covered this in the first video, you've got step and direction signals located on the front of each axis. So on X-axis, step, pin 2, direction pin 3, Y-axis, step, pin 4, direction pin 5, Z-axis, step, pin 6, direction pin 7, and A-axis, step, pin 8, direction pin 9. And again, a lot of things people overlook when they're purchasing this driver is there's also the DB25, which is telling you that these are the pin allocated from the DB25 parallel port cable. So if you ever wanted to go back and just do a quick review or brush your knowledge up as far as how you're going to set this up in your motion control software, you know your step and direction signals for each axis and which pin is allocated to the cable. So your DB25 cable, pin 2 is allocated to it, and DB25 cable, pin 3 is allocated to it for your X-axis. So step, DB25 pin 2, direction, DB25 pin 3, and that would give you the actual port pin number for Mach 3 or whatever motion control software you're utilizing. That being said, that's all broken down. If you have any questions, that's all on the front of the drive. That all pertains to what you're seeing on the front of the drive. The next thing I want to point out, and again, all this information is in the user's manual. That's why, once again, I want you to review the video. I've already posted the first video on the overview of the manual. You're also going to see you've got your A, and then it's got a wiring schematic, and then you've got your B in a wiring schematic, and then you have your R symbol, which is your resistor symbol for pins 5 and pin 1. This is where your resistor goes, 5 and 1, and this right here, A and B, are your two polarities for your stepper motors. So you've got 6, 7, 8, 9. Those are the only 4 pins on the DB9 connector, the male connector, excuse me, that you will be hooking up for your stepper connections to the G540. Another thing to pay attention to, if you want to cross-reference, which is really, really cool, I'm going to see if I can zoom in and let you guys see it. If you look close enough, you can see the DB9 connectors even have numbers allocated on them. So on the female connector and also the DB25, let's see if I can zoom in and see it. There we go. You can see all those numbers really clear. If you ever had a question, you could simply look at that, plug in the cable, and go through and track what number is what. Now, I also have a male connector here for the DB9, and you could do the same thing. You could just simply plug it in, write down and record all the numbers associated with each plug on the DB9 female and allocate it to a male, so you know exactly what you're doing. Again, the male, and I'm going to get onto this next, I'm going to cover basically the pinout on it, what you're dealing with when you're dealing with soldering. But in general, you can see, once again, all your numbers are right across the DB9 connector. You also have all your numbers allocated to the parallel port of the DB25. So essentially, you've got all your information. Again, you've got your power and fault light, power being green, meaning go, fault meaning red, which is real basic. Red stop, green go, we know all that. Charge pump, again, is on this side. I leave charge pump off. Most guys, I don't know anybody, honestly, that leaves it on. It's just basically a signal receiver to let them know that the DB25 is plugged in. I leave it off. All my drives that I handle usually ship with it off unless I'm requested to leave it on. So that being said, and then last but not least, you've got your trim settings, which again, you can go in here and actually trim each motor individually once and only once after it's been hooked up to your chassis and you're happy with your chassis settings. Then you would come in here and finalize the settings by tweaking for an audible setting of the motor, depending upon, once again, what you feel sounds good. It's more of an audible sweet spot. You're looking for that low kind of hum. You're not loud. You'll know when you hear it. I mean, you'll know what sounds odd and what doesn't sound odd. You're looking for the sweet spot by the motors acting in a more quiet manner, so to speak. Again, it's totally optional. You do that after. It's not going to affect anything on the long run, but it is there to let you go through and do the testing. So as far as everything else goes, now you've got the breakdown on the drive. The drive itself on the back, again, terminal block is set up with pin 12 being on this side to pin 1 being on this side. I know that because I'm building systems all the time. You guys don't have to memorize that. Once again, please review video 1. I cover that with the manual. There is a template in there to reflect what terminal goes where and all of that stuff, because again, you have your input, your output, your VFD, your power, and your e-stop. So these are all things to think about. You'll go in and you'll verify all that. You don't have to memorize that. I'm going to turn the drive over now, and I want to cover one of the biggest questions that I get asked. How do I attach heat sinks to the G540? Well, if you look at the back of the drive, we know that this is an aluminum chassis, okay? Honestly, if you're going to attach heat sinks to it, the best way to do it is you're going to definitely use an epoxy compound, and the epoxy compound I recommend is Arctic Silver. Arctic Silver has been on the PC market for quite some time. It's used to attach heat sinks or anything you want to transpire heat to a metal heat sink. Honestly, there's other ways to attach. I personally prefer epoxy because I know it's going to be the most efficient. Gecko Drive recommended it as well. It's not cheap. It's about 10 to 12 bucks a little vial of it. Again, you only need a very little amount. There is no stress put on the heat sinks once they're applied. The big thing is you want to prep this surface in a way ready to adhere properly with the heat sinks. And the way you want to prep this surface is you want to scuff it with either a probe like this, something like a scraper. I'll see if you can see that. You see the tip on that's very sharp. You can scratch it. You can use sandpaper, whichever way you want. You want a nice textured surface so that gives you your chemical bond a little more adhesion with a mechanical bond. That being said, you want to go through, scratch everything up here, scratch your heat sinks on the back where you're going to make your adhesion, and then what you want to do, and this is probably the most critical part, is grab some acetone and clean both components really, really well. And the idea is so that you remove any oil or residues from the dirt from you scratching and scraping. You want there to be a perfectly clean surface. The cleaner the surface, the better. It's just like painting, guys. Remember one thing. You're finished with painting or you're finished with gluing something, all is determined by your prep. So with that being said, take your time, do your prep right, let the drive sit, whether it be a couple hours overnight. Arctic Silver is usually like I think they claim it a 5-minute epoxy. I let mine sit overnight. That's just me. Everybody does what they want to do. You got so much other stuff to worry about as far as wiring and that. Usually you can let it sit overnight. The big thing here is going through, taking your time, and once again, get this drive nice and roughed up. Once it's all roughed up, go through, clean it well. I use a rag, usually with again, soaked in acetone, a little bit of acetone. I'll go over it. My big thing here is you want to make sure that there's no residue left, and preferably no dust or anything. You want this really, really clean so that the bond is clean. So once that's done, heat sinks are on, you're pretty much good to go. It's very, very simple. I usually just apply the epoxy to the back of the heat sinks that have been roughed and cleaned. And again, this base would be all roughed and cleaned with the acetone, and then you just apply it and you're set. Let it sit overnight. So that basically covers then the cooling part of the Gecko as far as adhering with your heat sinks, adhesive-backed heat sinks. That's the next topic because I get asked about those a lot. Do I use adhesive-backed heat sinks? No, I don't. And the main reason I don't is because adhesive-backed heat sinks, first of all, are garbage. When I say they're garbage, they're not designed for this type of hot application. The heat that's generated by the Gecko is far too hot to utilize adhesive-backed heat sinks. So please, I cannot emphasize this enough. If you're looking at a seller that's selling them and you want to buy them from them, remove the adhesive on them, that double-sided crap tape, and do yourself a favor, do it right, buy the epoxy. It'll transfer heat much better, and it will also do it with a higher volume in the sense that it'll withstand more the higher temperatures generated by the drive. A lot of people don't realize that. These drives get hot. Comfortably, it's 160 degrees. I've seen them go up to 200 degrees, and it's usually nothing there. I mean, it's about normal. Especially in a chassis, you can rest assured, without this drive being heat sinked and without a fan actually either blowing over the heat sinks or excavating heat along with the heat sinks, you're going to have issues. So, and maybe not right away. You know, some guys get away with it okay, other guys don't. I say do it right the first time and you don't have any issues. See, you eliminate the issue before it happens and you're good. Does it cost a little more money? Yeah, it does. Is that why I'm telling you to do it because I sell them in my store? Not really, because you can do what you want. Bottom line, that's the right way to do it. You wouldn't run a computer without a heat sink and a fan. Don't run this any differently and you'll be fine. So just keep that in mind. The next thing I want to cover, because I get asked this a lot, I'm just going to bring a couple items in. Wiring the Gecko. Let's see if I can actually have zoom in here. Let's see. Okay, it's not really picking it up, but let's see. Anyways, I gotta buy a new camera, it looks like. Okay, it's 300 volt rated 20 AWG wiring, and it says 300 volt right there. Let's see if I can pull it out. There you go. It's 300 volt. I like using the wiring that is rated to 300 volt. It's a little coarser, a little thicker. It is stranded wiring. And again, these that I'm showing you for an example, it's just an example. These have not been tinned yet, but this is what I typically power the Gecko with. It's excellent wire. 20 AWG seems fine for the terminal blocks. It fits in really nice, and it'll easily handle the power that you're sending the Gecko, be it 48 volt or even the gamut, you know, whether it be 18 to 48 volt. Okay. Other than that, now we're going to cover the DB9, and that's why I just showed you the wiring, because the DB9, you can see right here, and I covered this a lot, the DB9 pins are tiny. So essentially what you're seeing is this is the male DB9 that you will be soldering if you choose to solder to do your motor connections. These pins are absolutely tiny to solder with, and to give you an idea, just scale, for guys that aren't familiar with them, you can see just how small that is in that sense, because realistically these are used in old data cables, used to use them very commonly, and the largest wire diameter you used to see was 28 AWG. With the Gecko, I would say honestly the largest I was able to use was 18 AWG when I make my pro cables, and I'll tell you, it's a tight fit. It can be done, but it has to be done right, and it's a tight fit. So just so you guys can see what you're dealing with here. And again, that was why I created the solderless connectors, because dealing with these type of connectors, if they are not soldered properly, if you make a contact point on if one actually runs over from the other, from here to here, or vice versa, if this goes to there, you can have serious issues. You can blow up the drive, all kinds of problems. So ultimately what you're looking at is a 20 AWG piece of wire. You could see just the difference of how that fits in there. It's a very, very natural fit. I mean, going much bigger, once again, 18 to AWG is possible. It's definitely not necessary with the Gecko. The Pro cables in my store are designed around larger drives. They're really not designed for use with the G540, but they can be used. I mean, I get guys that'll buy them. They think they're doing themselves a favor. I don't see a difference. No one else has ever seen a difference. So, again, it's really just a question of what you want to use. Overall, though, the pin setup here is very simple. You're only connecting these 4 pins. Here's 9, 8, 7, 6, and I'll go backwards, 6, 7, 8, and 9. When this is set this way, what you're looking at, here is 6, 7, 8, and 9. Okay, and this I know because I assemble solderless connectors all the time. And again, these are the only 4 pins you'd be concerned about hooking up. And then again, these rear pins back here. So to give you an idea of what that looks like, I've got one pre-done. This is a motor tester cable that I use. And I'm going to show you now. You can see that resistor. And that resistor is soldered in, and I'm not tooting my own horn, but I've practiced a long time on soldering. And you can see the solder joints are perfect. They're clean, everything, you have good flow. The resistor's in perfect positioning for you to close your DB9 clamshell. I'm going to reverse this so you can see all the soldering there. Let's see if I can zoom in. Get that in. Here we go. There we go. So overall, there we go. You can see how clean those solder connections are. Flux was used on all of these. And again, the terminals are very, very clean. There is no overflow. You can see the soldering is clean. You want to be careful. You guys can see just how close that is. So if you make a mistake and it makes contact, you're going to have a problem. Either you're going to get a fault light on the Gecko, or you could short the drive out. So take your time. If you're not sure of soldering, have someone do it that is sure, but you really want to take your time and do it right. Now, what you're seeing here with the resistor is you're seeing how that gets to pin 5 and 1, and then you see how it's set up. One pin goes to pin 5 or 1, and one pin goes to pin 5 or 1. I don't memorize 5 and 1 because it's a loop. There's no net. It's not required to. You're just connecting one end of the resistor there and one end of the resistor there. Figure it on. I always look at it as it's the longer 2 of the actual terminal. So if you look on this side, there's only 4, and if you look on this side, there's 5. So really, you just can't go wrong by going one end to the other end, and you're done. Okay? The big thing here is take your time. And I mean that seriously. I get a lot of guys that want to rush and get their stuff done. That's when mistakes happen. So just take your time and do it right, and you will have a perfect connection. Heat shrink on a DB9 connector is not required. I've seen some videos where guys like to use heat shrink. Again, they were not designed for heat shrink because these terminals are so small. You can see how small that is. And when you put the DB9 clamshell on, it's going to insulate these automatically. So if you use flux, use the solder correctly. I know some guys say, well, you know what, my solder's got flux in it. Guys, use flux. It costs nothing. You buy it once, you do it right, you make sure your contacts are clean, and all your soldering comes out perfect. Okay? It's the right way to solder. Anybody who's done professional soldering will tell you that's the right way to solder. Plumbers use flux. It's the same principle. Metal is metal when you're dealing with that soldering type principle. Everything needs to be clean. So do it right. Flux is really the best way to go, and you can see, once again, look at the clearance in that. I mean, see if I can get there we go. Look at how much clearance you have there. I mean, that's what we're dealing with, guys. So it has to be done right, and take your time. Again, the resistor format, very simple. You can see how to hook it up. And again, here, you can see. Now, the wiring I'm going to cover with, because these wires are actually color-coded to the Gecko's pinout, meaning 6 is blue, 7's red, 8's green, 9's black. Okay? Now I'm going to give you the polarities for your stepper motor. Okay? 6 is B minus, 7 is B plus, 8 is A minus, and 9 is A plus. So realistically, what happens if you get a stepper motor that does not match this wiring coloring? Is that a problem? No, it's not a problem. What it means is you're going to review your manual, your user's manual. You're going to review what your manufacturer gave you as far as the polarities. You always want to get that first so you know what your motors you're dealing with. You do want 4-wire steppers. I would advise against buying 6-wire and 8-wire, not because you can't use them, but why make it more complex? You're just going to have to tie those wires off. it's really kind of silly to do that. You're buying this drive, uses bipolar steppers, 4-wire. Stick with the 4-wire, keep it simple. It's easier to wire in. And on top of that, you won't have to worry about later on any issues with wires coming undone or accidental contacts being made. This is the easy way to go. So if your motors contain more wires than 4, you're only going to be using 4 anyways. If, however, you're smart enough to get the 4 wires or the 4 lead steppers, what you want to do is, if you're noticing that the blue wire does not match on, let's say, pin 6, it's blue for the Gecko, and that would be B-. You're going to take your motor and find out what B- the polarity is. If it's red on your motor, we're going to go by polarity. Polarity is the master of the DB9 hookup. So remember something, regardless of the color code, I color coded these to the Gecko. I also color coded the solderless connectors to the Gecko because that's what it was designed to be used for. However, you can still use any motor that you choose by simply knowing what is your polarity of your motor. So if your motor is, let's say, for pin 6, which is blue for the Gecko, but you know your motor's B- signal or B bar signal is going to be yellow, then you would hook up the yellow wire here, because pin 6 for the Gecko is always going to be B bar or B-. So that's the easiest way to think about that. Always go by the polarity of the stepper, and that's how you'd wire these. Other than that, you want your soldering to look as close to that as possible. This is best practice. This is proper. You will not have any issues with this. And again, you'd be dead on. That's a perfect setup. And again, the resistor is the same thing. Take your time with your resistor, because it's going to keep the motors from running even hotter than they already do. We already know steppers get hot. Watch my other videos. That's normal. The resistor reduces the current from the Gecko down to 70% only when it's at idle to your motors. So if your motors aren't doing anything, this little guy right here saves your motor's excess temperature. Now, does it matter? Not much, but it matters in the long run for longevity. So it's proper. If you can save heat from, destroying any equipment, I say, what's it going to take to solder, 2 more connections? It takes seconds. Just take your time and do it right. Again, you can see how I cut the resistor. It fits in perfectly. There is no issues, and you're set to go. So once again, that covers all that. You guys now have the lowdown on that. I'm going to bring the drive back in. Or actually, I'm not going to bring the drive back in. I'm going to cover the DB25 parallel port cable. Okay, straight through cable, real simple. All of these pins that you see right here, what a straight through cable is simply stating that all of these pins you see here wired are exactly mirrored to this end. So what you see here with all these pins, these all represent a signal on your G540. Plug it in, plug this end into your computer. You do want a male-to-male cable. So if you don't buy from me, make sure you buy a straight-through DB25 male-to-male cable. And why is that? Because the Gecko utilizes a female plug-in, and so does your computer's motherboard. So you want to make sure you're using the right stuff, because nothing sucks worse than when you're all excited to hook everything up, and guess what? You got the wrong cable. That sucks. So just take your time, do it right. You want that. You also want to make sure, once again, I'm reiterating from the first video, you want your settings in your BIOS for your computer to be set at EPP for your DB25. If it's set at EPP, you'll be all set to go. Plug it in and go. That's basically it. It's going to send and receive signals, and that can hold you up from actually sending and receiving signals if it's not transpiring the data correctly through the cable. So pay attention to that. Again, my cables are gold-plated. All of my packages that come with the G540, my extensive packages, other than just the bare system with, the bare driver with a power supply, come with the cable. So once again, if you go through my store, guys, you're going to realize all of my packages make sense because I know what you need already. And I've built them so that they're intuitive to what you need. So think about that. That also brings your price down. I'm sure you've already figured that out, being that I am the cheapest online for what I sell. The next thing I'm going to cover, bring the drive back in here. Just let me move it back a little bit. Okay. I want to cover with you, and this is a question I get asked all the time. It's probably the most annoying question because there's a lot of information about it online, but I understand a lot of guys are learning, and a lot of guys are really, really fascinated with running tandem axis machines where they have two motors driving one axis. Guys, I cannot emphasize enough, if you're a novice and you've never had a CNC or any type of machine that's automated in front of you, I cannot tell you enough how I recommend against getting a tandem axis machine. There's a lot more variables there. There's a lot more troubleshooting there in the event something happens, and they're just tedious to set up. I mean, that being said, it's not impossible. I'm just telling you, if you're looking for the quickest sense of glory, so to speak, I would definitely stick with a 3-axis system or a 4-axis straight system. You're fine. Once you start getting into running tandem motors on one axis, you're dealing with a lot more variables with mechanics. You're dealing with, just in general, a lot more variables. Remember, anything you do to your system is the variables. Okay, if I go from a 3-axis to a 4, that's my other variable. If I go from, adding a parallel port to now switching to USB, that's a variable. All those variables change everything directively as far as troubleshooting. So if you think in that terms, that's the easiest way to understand a CNC, how complex it is. You're not just plugging, a lot of guys think you just plug it in and go, and then if you run into a problem, then you troubleshoot. The best way to troubleshoot is start analyzing from the beginning so that there is no troubleshooting. Meaning, once you guys start getting your stuff all plugged in and getting ready to power on, you should have a pad ready to document everything until you understand what you're doing fully. Now, I covered this in the first video series. I've covered this in a couple of my other videos. This is what pro-grade manufacturing facilities do, guys. You're no different. I don't care if you're doing it for a hobby. I don't care if you're doing it, for profit. The idea is to learn your equipment. 9 out of 10 guys that are purchasing this, I would say over 9, probably 10 out of 10 guys have very, very limited education in this. And even if they have education in full-scale machines, there's still some things that are variables here. Actually, there's quite a few things that are variable here that are not in full scale. So what I would say is document, have a log ready, start documenting everything about your drivers and your hookup, what you're noticing. And in this way, if something ever arises, you can go back to your notes and have your check boxes and say, okay, I did this, I did that, I did this. Trust me, it'll pay for itself very, very quickly, and you'll learn twice as fast. So that being said, covering a tandem axis setup, meaning if I'm having my y-axis driven by 2 motors or my x-axis driven by 2 motors, you would have x-axis and a-axis, or y-axis and a-axis. Why am I picking a-axis? Well, a-axis is your 4th channel. Okay? What I mean by channels is you have each axis, 1, 2, 3, 4. I like looking at them as channels, 1, 2, 3, 4. The Gecko looks at them as channels. Okay? You will never, and I've seen this done online, you will never have 2 motors connected to 1 DB9. I'll reinstate that again. You will never have 2 motors connected to a single DB9. Don't do it. It's not right. It could blow the drive up. It probably will blow the drive up, even if it doesn't do it in the beginning. It's incorrect. The way to properly have tandem axis hooked up is you want A-axis hooked up with Y-axis, or X-axis hooked up with A-axis, or vice versa, A-axis with X, or X with A with A with Y. Doesn't matter. A is always your alternative extra axis. So if you decide you want 2 motors hooked up, then you're going to have a motor hooked up here and a motor hooked up here. Now, how do I set up the drives, or excuse me, how do I set up the drives and the motors to initiate that they're going to move together? You go into the motion control software. There's videos online for it already. I'm not going to cover that explain explicitly how to do that. It's all done through your motion control software, whether it be Mach 3 or UCCNC. That's how it's done. However, you still need an extra motor cable, of course. And again, you will not have any more expandability. The drive will be maxed. Okay? That's one of the reasons I invented my 6-axis system, because for guys that like to run tandem motors, the 6-axis system gives you a lot more expandability. For the guys that are running tandem motors on one axis, you will realize real quick the Gecko's a 3-axis driver. So you're basically losing that axis. So take that into consideration when you're doing that overall. The next thing I want to point out, and probably one of the most overlooked things, is if you guys are going to do a tandem axis machine, 90% of the time, I'd say 95% of the time, it's easier to just use a larger stepper. And when I say that, if you think about it overall, time is money, and even if yours isn't time is money yet, it will be very shortly when you start figuring things out. If you think about it, to spend the extra 20, 30, 40 bucks on a motor once and know that I don't have to sit here for 3 hours trying to figure out, is this right? Is that right? Why is my settings off? I already calibrated in Mach. Something isn't right. Trust me. I've been hit on all axes, so to speak, with questions. And I can tell you truthfully that a single axis system, meaning that one motor runs one axis, is the best way to go. It's the easiest and it's the simplest. As far as maintenance goes, it's simple. That's the easiest way to go. There's still stuff involved, but not nearly as much as when you're running two motors on one axis, because let me tell you something, that axis has to be set perfectly in order to have those two motors run. And it is very possible, there's quite a bit of them out there that are running fine with that. But again, if you ask the user when they were a beginner if it was easy, so to speak, some guys say yes, some guys say no. I'm saying in general, it's more to learn. So it's just something for you guys to think about prior to getting involved with running, tandem axis, whether it be, again, Y and A or X and A. That's something to think about. Other than that, standard hookup is pretty simple. X, Y, Z. That's all basic. I mean, there's really not a lot of complexity. Again, you would just allocate X here, Y here, Z here, and so forth. A-axis, if you're going for a 4-axis system, is very basic in itself. Again, that would be a rotary axis, and that would just be a one more motor cable and a soldered connection or solderless connector, whichever way you want to go. So overall, that setup is pretty basic. Again, the Gecko now has been covered thoroughly. You basically have got a lowdown on everything that's involved with her. The big thing here is time, and when I say time, take your time, do your research. Now you guys have got videos. I didn't have these videos when I was learning about all this neat stuff. I mean, I've again delved into it. I came from a little more educated background, but I still had a lot to learn with this, and I'm still learning a lot with this. But one thing I will tell you is that I wish there was a video series out for me, because I didn't have that. Now I got a little more time, so anything I can do to help myself educate you and help you educate yourself, I think it's definitely going to be a win-win all the way around. The big thing here is, as I stated, your time. Take your time, do your research. If you're getting into CNC and you're looking at buying a machine, once again, look at overall what you want to spend as far as drivers, and you'll soon see value-wise with you're getting actually 4-axis or 4 channels, 1, 2, 3, 4. You're getting a breakout board, which is actually built into here, which actually encompasses, if you choose, and again, I'm not real big into it. I covered that in the first video about using all the extra ports and all that crap, but you do have it available. If you ever choose later on you want to add stuff, you can. If you think about it all, what you're actually getting, dollar for dollar, definitely the best value on the market. Not to mention you also have American support, which is amazing. And the warranty that Gecko encompasses is excellent. One more thing I want to cover, and a lot of guys don't think of, and this is something that you guys really want to pay attention to, because I can guarantee for some guys, it's going to save them a lot of money. Okay? I covered this in the first video with about how a motor can be used, how a stepper motor can be used that's not 3.5 amp with the G540. Okay? If you are looking, we know that the G540 puts out a max rating of 3.5 amps. Okay? My first video covers that. The RMS rating is about 2.47 amps, because that's the square root, so to speak, for true RMS. If you think about it logically, okay, and a guy is looking at a big machine like a Grizzly, a heavy machine, and he wants to do it on a budget, can he use a G540 to power his machine? Yes, he can. One of the big concerns is, will this driver system be strong enough to handle a machine like that? Well, guys, I'm going to tell you something that's in the manual that a lot of guys don't even pay attention to, and I covered it in my first video, but I'm going to cover it again because it's very powerful if you think about it. If you purchase a motor that is larger in amperage than the Gecko can drive, you're going to get a percentage of the torque from that motor. So the example from video 1 that's in Gecko's user's manual for the G540 is, if you decide to drive a 5 amp motor with the Gecko and it's rated at a max of 3.5 amps, you're going to get 70% of that 5 amp motor's torque. Now think about that. You're going to get 70% torque available of a 5 amp motor. What that simply means is, if I hook a 5 amp motor to this and it's rated at 1600 inches of torque, okay, and I'm only going to get 70% of the torque, that's still about 1200 ounces of torque. So if you do the math on that, and you've got a Grizzly machine which is heavy, you can use a larger stepper motor than even the Gecko can support technically under the amp rating and still get motion appropriately. So how am I doing that? Well, I don't need that amount of torque. So I can use a larger stepper with this driver system to power a larger machine, because I can use a larger stepper at a lower cost, because usually a stepper, even in that caliber, is going to run you a little over probably about $120, $130 on a low end. The high end, it depends on where you get it manufactured. That's another thing, another video in itself, but guys, I'll clue you in on something. They're all manufactured in China, so do yourself a favor and look at the facts. Honestly, that's the way to save money. And what I mean to say is, for the guys with the larger machines, and I get occasionally guys that'll ask me this, but I want to show you just how powerful this driver system is. If you hook a 1600 ounce stepper up, you can still get, if it's rated at 5 amps, let me clue you in on all the details. If that 1600 ounce stepper motor is rated at 5 amps, and you hook it up to this driver system, you still will be able to produce about 1200 inches of torque. Now, that being said, that shows you just the potential of this drive. I mean, you can run a Grizzly mill with basically a full-scale mill with a Gecko, pending you use the right stepper. All you have to do is use a torque that's much higher than you would need, and you can offset the torque even with the amp rating of the drives. So that's what you're basically doing. You're offsetting the torque. You know you're not going to get 1600 ounce out because you don't have the max amp rating. However, if you get the percentage, if the percentage matches your machine's required torque, you can use that motor. So I really want you to think about that. If you're confused about what I'm saying, just watch video 1. I hope you're watching that. Again, I'll keep reiterating that, but it's very, very powerful what I'm telling you. Because for the guys that are looking at creating much larger systems, that's your best bet. Go with a larger motor, whether it be NEMA 34 or a 23. Difference between NEMA 23 and 34 is the chassis, guys. The 34 is beefier. The 23 is not so beefy. But is it required? You know, look at that overall. I came out with 600 ounce NEMA 23s for that reason. You know, a NEMA 23 at 600 ounces is massive. That's a lot of torque, guys. So, I mean, a NEMA 34, if you're getting 1,000 ounce inches on a NEMA 34 and can drive it with a G540, you're going to save a boatload of money. So think about what I'm telling you. What I just told you there will really make you a really massive system at a lot less money. The big thing here also is I get questions about the G540 versus the individual G251Xs. Well, I use the G251X in my 6-axis system. And the thing to consider about the 6-axis system is the G251Xs are the exact same drives in this driver, but they're the individual drives. And the difference is they have a terminal block so you can hook the wires up, okay? These terminals that are, the G251s that are in this do not have the terminal block. They have a plug. They just plug in. So essentially, you're getting a 6-axis Gecko G540 with my 6-axis system. The difference is, with my 6-axis, you can add a drive at will or take a drive out. So if I wanted 5, I can add a drive. If I wanted 4, I can subtract a drive. It comes standard with 3. You want to add up to another 3, you can. This drive is locked in. You cannot do that. So for expansion, I gave you the same performance of a Gecko. The difference being is that you can expand or decrease its capacity at will. So that being said, the pro grade drives Gecko offers, the G201s, and all the other new versions that they've come out with that are rated at like 80 volts. Why would you need them? Well, let's cover that real quick. If you have a large table, if it's, let's say, 8 foot by 10 foot or larger than that, the 80 volts comes in real handy because the voltage is really going to give you your rapids. The higher the voltage, the faster the rapids. Why? Because the motor's going to spin faster. It's common sense. So really, at 48 volts, you can see the Gecko can handle 18 to 50 volts, the G540. Do you really need 50 volts? Even on a small table, guys, that's a lot of speed. Your table speed will go up on a Chinese configuration, huge. For my guys out there looking at this as a retrofit, there's no better. I recommend that highly in the sense that first you'll have peace of mind with an American warranty, and aluminum is the same whether you buy it from China or you buy it from the US. It's aluminum, guys. It's not any different. It's not going to be milled any different. They use the same machines we use. The big thing here is their quality. 9 out of 10 of the aluminum chassis coming from China, I'm just going to cover it real quick, they're fine. If you change the electronics, they are fine. They become amazing machines. Matter of fact, I have 3 of them. So I have 3 6040s, and I can tell you they're amazing machines when you combine them with a Gecko. And they're set properly. That being said, you have a lot of potential there. But once again, the voltage rating is only required when your table is large. If your table is large, you want the higher voltage rating because it's going to cover your table much faster. And again, that just keeps your machining time down. If it has to cover a lot of distance and it's going slow with a 20-volt power supply, you're going to take more time to machine. When it's actually machining, you're not machining fast anyways, for most cases. So, again, very seldom will power supply really dictate speed of machining in that sense. It's really just rapid movement. Think about what I'm saying. It's purely logical. This drive, when anything, I would say 4 foot or under, and you're perfect. I would say, honestly, you're set to go. If you have a Grizzly, again, you're not looking at a large machining space. This is excellent. So, really, it's just a question of what we're talking about, but hopefully this video has educated you. I've covered a lot of things that I've never even seen really covered. I've wanted to do this for a while. If you guys have any questions, again, I'm Vince. I'm at eDealers Direct. I engineer with these drives all the time. I've been doing it now full time. This is what I do. I mean, this isn't a hobby to me. I make money. I profit with this. You can rest assured. All of my designs I profit from mainly because of my designs with this. So if you have a question, if it's something I haven't come up with, I mean, I'm always learning new things. You guys teach me new things also. But Gecko is also available. Bottom line is that you have support. Any questions you have, message me. But please watch video 1. And then watch this. Hopefully you're watching this after. And again, if you have any more questions, just message me. But in general, I think this covers pretty much the entire lowdown of the G540. As far as wiring schematics and that, please pay attention to video 1. You're probably going to see that immediately. I cover the wiring schematic that's actually included in Gecko Drive's manual. And in this way, you guys are set when you get your system. You're all good. So just so you guys know, once again, I appreciate all your support. Everybody that has been messaging me and been really supportive of these videos as far as it helping them and getting them ahead and making them really understand what they're doing. I really appreciate that. And if it helps you, I wish you the best. If you have good luck and you want to send me pictures of your machine, I'm always looking for that kind of stuff. So once again, I do appreciate everybody. I appreciate your patience as well. Take care, and we'll have more videos up for you as soon as I can. Take care.